So theoretical yield we can calculate using two reactant, and whichever the value is the least value you are getting from two reactant, and we consider that as the theoretical yield. Okay, but uh, theoretically we are calculating and you are getting a value. Say for example, if you are baking a cake, okay, you are baking a cake and your mom give you all the ingredients like maybe 200 gram of flour, 100 gram of sugar, 100 gram of butter, and maybe 10 gram of other ingredients. Okay, so the theoretical yield for that, you are adding all of this, and your cake must weigh 410 gram. That is the theoretical yield. But when you make, we know that some of the batter will stick on the vessel you are using, some of them may be spilled, and maybe there will be always the cake will weigh little bit lesser based on how good cook you are, or maybe how skilled you are. So you baked that cake and your mom weighed the cake and it is only 390 gram. So that is called actual yield. Actual yield is something which we are making in lab or here in the kitchen. Okay, so using actual experiment, okay, we are doing that experiment not theoretically, and what is actually produced is called actual yield. So always actual yield always lesser than theoretical yield. It will never be more than theoretical yield, okay? It will be lesser than theoretical yield. So based on the value of the actual yield, you can calculate how much percent you yield. Okay, so basically when you bake the cake, we know that you got only a cake weighing 390 gram. You are expected to get, your mom expected you to make how much gram? A cake weighing 410 gram. So that is your theoretical yield, and this is your actual yield, and you are dividing and multiplying that with 100 to convert that into percent yield. So that is percent yield. Percent yield is actual yield divided by theoretical yield times that with 100. Remember, when you do the calculation, sometimes you may forget what is the formula, but always the small value will be on the top and the bigger value on the bottom. Okay, if you did your theoretical yield calculation correctly. Okay, so if you are not getting if you are getting the opposite, there may be an error. So maybe in the question or maybe in your calculation, you had to double check. Okay, that is the last topic. Let's do one example question. Okay, it's asking calculate the percent yield if you combine 4 mole of aluminum and 5 mole of bromine and produced. Okay, that is very important. Okay, that produced, you are doing in a lab and you produced, that is called what? Theoretical yield. Okay, so sorry, my bad, that is called what? Actual yield, because that is produced in the lab. Now using this small value, you are going to calculate your theoretical yield. And remember, if the actual yield is given in moles, you are calculating theoretical yield also in what? Moles. So that is easy. Let's go and start from reactant. Let me go pick my blue pen. Okay, reactant 1. Reactant 1 is what? 4 mole of aluminum. Okay. Now we need mole ratio between moles of aluminum to what we are looking for? Sodium chloride. Moles of sodium chloride. So we need an equation. Okay, there is a mistake. It is not sodium chloride. It's a typo. Okay, we have to find aluminum bromide. Okay, Okay, let's go ahead and write the equation. Aluminum, let me write here. Aluminum combines with the bromine to form aluminum bromide. There are 3 bromine, 2. So we will multiply each other. There is 2. And this is 2. So now there are 2 aluminum and 2 aluminum. So we got a balanced equation. Okay, we need to erase this. This is, we are looking for what? Moles of aluminum bromide. Everyone just make the change in your question. That is a mistake there. Okay, so 2 mole of aluminum will produce 2 mole of aluminum bromide. So the calculation is easy. The 2 and 2 we can cancel. So 2 and 2 will cancel. Moles of aluminum will cancel. So your answer, theoretical yield, we don't know whether it is a theoretical yield or not. Let's write that first. Moles of aluminum bromide. Okay, we got that from the first one, first reactant. Let's go do that with the second reactant, which is 5 mole of bromine. So we'll write the mole ratio. How many moles of bromine there in the equation? 3 mole of bromine producing how many moles of aluminum? 2 moles of aluminum bromide, and you will get, what is the answer you are getting? You will get 3 point, let me write with the different colors. Be consistent, okay? We'll get 3.33. You check your calculation, okay? Mole of aluminum bromide. Okay, now we have to decide which one is a theoretical yield. Look at both value. Which one is the lowest value? This is the lowest value, and this is the limiting reactant. If you want to answer that too, so this is your theoretical yield. Okay, so I'm gonna calculate percent yield is equal to theoretical yield, always mess up, actual yield divided by theoretical yield times 100. Okay, actual yield is given in the question, which is 2.58, and theoretical yield one you are getting from dimension analysis, which is 3.3. Both are moles of aluminum bromide. Okay, and times that with what? 100. Right, I'm going to the curve because I don't have space. Okay, so now you will get 78.2% yield of aluminum bromide. Okay, that's how you are doing the calculation. On your lab, s'mores lab, you have to calculate the percent yield of s'mores. Okay. Question, do we need one more practice? Let me see if we have anything in grams. Oh, those are all more questions. You can do it. I may do one question practice. Like I'm going to do this one. Let me see where that is in gram. When phosphorus is produced from reacts with the phosphorus, when 100 gram of reacts, so what is a theoretical? That is actually asking only for theoretical yield. Then there is, okay, there. Let's do this one. Okay, first, as always, we are going to do what? Balance the chemical equation. This is 4 phosphorus, there is 4. Okay, I'm going to multiply this with 4. Now there is 12 hydrogen, so I'm going to multiply with the 6. Look at the oxygen, 60. Okay, that is balanced. Okay, now go ahead and read the question. You have 100 gram of this one, phosphorus, tetraphosphorus decaoxide, and 200 gram of H2O. We are going to find the theoretical yield. Okay, let's go start from reactant 1. Start the T chart. We'll write the given always 100 gram of P4O10 tetraphosphorus decaoxide. And you have to calculate the molecular mass. 284 gram of P4O10 is 1 mole of P4O10. Okay, we need to go one more step further. I'm going to find the grams because the second step you can see the actually it is given in grams. Okay, so here as per the equation 1 mole of P4O10 is giving 4 mole of H3PO4. Let's continue. 1 mole of H3PO4 we need in grams, so we need the molar mass, which is 98 gram of H3PO4. Okay, you can stop there mole and find the theoretically then convert, but I always like this. That's up to you. You will get 138 gram of H3PO4. Okay, let's do the one in the calculator maybe. Okay, let me see this. Okay, next reactant 2. Okay, I'll use a different color so that you can see that. Okay, so 200 gram of water, and we know that molar mass of water 18.02 gram of water is what? 1 mole of water. We have moles of water. Now write the mole ratio. 6 moles of water in the equation, and it produces same. Everything after that will be just copy paste from the previous question. That is one advantage on limiting reactant questions, because okay, now you got 98 gram of H3PO4. I believe that molar mass is correct. Okay, you have to double check. Okay, so you are going to do the calculation terms. So you will get 725 gram of H3PO4. I believe that is correct. Okay, let me double check because the value is very big. 200, 498 divided by 18.02 by 6. Yes, I think that's right. Okay, so now look at the answers. Which is the value, lowest value? Okay, this is the lowest value and this is the limiting reactant. Okay, I'm gonna write that there using a different color. Okay, this is your theoretical yield, this is your limiting reactant. Okay, now you have the theoretical yield. Let's read next question, which is, if the actual yield is this much, what is the percent yield? Okay, let's go and calculate that. Percent yield is equal to what? We'll write actual yield, which is given in the question. Theoretical yield, we got that from the T chart. So 126.2 gram of H3PO4 divided by 138 gram of H3PO4, then times that with 100, and you will get what? You are a good chemist. You got a good percentage yield. Percentage of H3PO4. Okay, so there will be at least 2 questions like this. Maybe 1 question, don't remember in my top of my head, on your test. So be practice, complete all of this. That's it for today. And my A-Day class, you all need to finish this practices, and there will be additional practice you can get from the